Let's have a word about end behavior. 1.3 notes here, domain and range, and for the first time we're going to be introduced to arrows and what exactly that means for us in this scenario. So the one thing I want us to consider is end behavior, how the function appears or moves at both ends of the graph. So these arrows that we see here are pointing in specific locations. We didn't have to worry about the direction of where arrows are pointing for the most part so far in this class because we just had dots like the previous problem example that we were looking at. But here I want to focus first on the left and the right, how these arrows are pointing to the left and to the right. So for instance, this arrow right here is pointing to the left, and this arrow is pointing to the left, and this arrow is also pointing to the left. All of that is true. Certainly don't appear the same, but they're all pointing to the left. And then the other ones, this one's to the right, this one's pointing to the right, and this one's pointing to the right. Now we need to understand that when I'm on a graph and I'm talking about the words left and right, those are phrases that are all about x values. Right? So this conversation here is completely about x values. And so when I consider that, I need to understand that when I see an arrow, that is symbolizing that this function is traveling past what we see image-wise on a piece of paper or on a graph or even on Desmos. It's traveling past that and it's going towards infinity. So what we need to kind of sort of understand is that there is a negative infinity, a number that we can't calculate to the negative side, and there's a positive infinity, a number to the right that we can't calculate. So when I see the word left for end behavior, I want to make sure that I understand that my x value is traveling to negative infinity. All of these x values, all of these arrows are traveling towards negative infinity. And I'll go ahead and circle them just so we know that it's not like a subtraction problem or anything like that. It just means that the x values, if it's pointing to the left, is going to negative infinity. The right would be going to positive infinity. And again, left and right are both x value words on a graph as we travel. So if I see an arrow pointing to the right on a piecewise function, or any graph for that matter, I know that it's traveling all the way to the left. If it's pointing to the right, I know that it's traveling to positive infinity. The same is true for up and down. This one's a little bit more that we have to be careful with. And we are looking at the specific direction of the arrow, right? So for instance, I have this arrow right here is pointing up. This arrow is pointing down. This arrow is pointing up, and this arrow is pointing down. Now, obviously, you might have already noticed that there are two arrows also that are staying flat. Those are our constant functions, right? So if it's a constant, I don't necessarily have to worry about it. It's not really going up, it's not really going down. When I see the word up and down in on a graph, then I know that the y value is traveling to either negative if it's down or positive if it's up, infinity. And that is a y value word. So again, this one right here, whenever I see the word up, I know that the graph is heading towards positive infinity. Just for the y values are going to continue to climb no matter what, and down, of course, for negative infinity. So as we move on here on the back side of these notes, we're going to have to pay attention specifically and actually start the conversation of picking out domain and range with these arrows. And hopefully the directions for that will help us understand a little bit better what exactly the domain and range is for each function.